For decades, battling cancer often felt like, well, a really broad assault on the body, didn't it?
Absolutely. Kind of indiscriminate.
But imagine a defense system so incredibly precise, it targets only the enemy cells, leaving everything else untouched.
Yeah.
Today, we're doing a deep dive into exactly that, a treatment called targeted immunotherapy. We're going to break down how this pretty revolutionary approach works based on the material you share.
Right.
The idea is to give you a really clear understanding of the core mechanism and, why it's such a potential game changer.
And our mission today really is to get our heads around how this therapy gets that incredible precision.
Okay.
Transforming cancer treatment from that sort of wide attack into, well, like cellular smart bombs.
Smart bombs, I like that.
It's about using your body's own intelligent defenses in a totally new way.
Okay, let's unpack this then. So targeted immunotherapy, it's not just general immune boosting, right?
Yeah, not at all.
It's about guiding your body's own immune system, guiding it to specifically find and destroy the cancer cells.
Exactly. Guiding is the key word.
So when we say targeted, what does that really mean compared to, say, older treatments? How different is it?
Well, what's really fascinating here is how it starts with the cancer cells themselves, their unique characteristics.
Okay.
Cancer cells often have these distinct molecular signatures on their surface, specific proteins, we call them antigens.
Antigens.
And crucially, these antigens, they're either not there or they're in really low numbers on your normal healthy cells.
So that difference is key.
That difference is precisely what the therapy exploits. It's quite brilliant, actually.
That sounds incredibly specific. So once you know these unique signatures are on the cancer cells, how do you actually signal the immune system?
Yeah, how do you point them out?
Exactly. Point them out and say, attack this without causing friendly fire.
That's where these things called monoclonal antibodies or mAbs come in. They're ingeniously designed.
Monoclonal antibodies.
Think of them like exquisitely engineered biological keys. Each one is identical, a clone.
A key.
And it's crafted to fit only one specific lock, that antigen on the cancer cell.
So super specific.
Highly selective. They act like signal flares, basically, marking only the cancerous cell for destruction. That way, you minimize the impact on healthy tissue.
Okay, so the antibody is the flag, the signal flare. It's raised. What happens next? How does our immune system actually, see that flag?
Right. How do our natural defenders pick up on it?
Yeah, that's the important question here, isn't it?
But this is where your body's T cells jump in. A really crucial type of white blood cell.
The immune system's soldiers.
You could say that. Highly trained special forces, maybe.
Yeah.
So when these T cells encounter a cancer cell that's been flagged by one of these monoclonal antibodies, they literally see that attached antibody. The unique flag tells the T cell precisely which cell to engage and destroy.
Wow. So it maintains incredible accuracy.
Exactly. While leaving the surrounding healthy cells alone.
Okay, let's make this concrete. A real-world example. HER2 positive breast cancer. I know in those cases, the cancer cells have way too much of this HER2 protein.
That's a classic example, yes. Overexpression of HER2.
So a specific monoclonal antibody, trastuzumab, people might know it as Herceptin, gets used. How does that specific antibody fit into the signaling picture we just discussed?
Trastuzumab or Herceptin, yeah, it's the perfect illustration if we connect it back. It's engineered specifically to bind only to that HER2 protein, nothing else.
Okay.
So once it binds, it does a couple of things. It doesn't just block the HER2 signal that helps the cancer grow.
Right.
But it also acts as that beacon we talked about. It helps the T cells identify and then very precisely kill those HER2 positive cancer cells.
So it's like a double whammy, blocks growth and flags for destruction.
Exactly. It's a beautifully orchestrated attack, really focusing on the cancer's specific vulnerability.
And the benefits must be, well, pretty profound compared to the older ways. This isn't just a small step up, is it?
Oh, absolutely not. The scale of the difference is remarkable. Think about traditional treatments, chemo, radiation. They often cause widespread collateral damage.
Yeah, the side effects everyone knows about.
Right. But with this kind of precision targeting, we're seeing significantly less harm to healthy cells. That translates to a completely different quality of life for patients.
So much less hair loss, nausea, fatigue.
Drastically reduced, often. But beyond just side effects, by guiding your own T cells, you're not just attacking the cancer now. You're potentially educating your immune system, helping it become more effective, and maybe even creating a lasting, stronger response against the cancer itself.
Okay, so let's recap the core idea then. Targeted immunotherapy is essentially about guiding your own immune system's T cells
The T cells.
to precisely identify and destroy cancer cells. And the key is flagging those cancer cells with special antibodies
Monoclonal antibody.
that target antigens unique to the cancer cells.
That's the essence of it. Precision targeting, stronger immune response, fewer side effects.
Amazing stuff. Which leads to a final thought, I guess.
Yeah, it does raise a broader question, doesn't it? Given how incredibly precise and effective this approach is, guiding the immune system this way. What other diseases, what other challenges might similar targeted approaches revolutionize in the future?
Right. If we can do this for cancer.
Where else could this kind of precise immune guidance take us? It really makes you think about the future of medicine, far beyond just oncology.